Hello students, I am Subhashish. Today we are going to learn the graphical representation of cumulative frequency distribution. Students, do you remember that we have represented the data through bar graphs, histograms and frequency polygons in class 9? Learning outcomes. After the completion of this lesson, you will be able to understand the concept of cumulative frequency distribution, differentiate between less than and more than ogive, learn how to draw cumulative frequency curves graphically. Apply the ogive to identify the median. Keywords from this lesson are median, quartiles, cumulative frequency, less than ogive, more than ogive, limits. Let us now represent a cumulative frequency distribution graphically. Note: to draw the cumulative frequency curves, it should be ensured that the class intervals are continuous, because cumulative frequencies are linked with boundaries but not with limits. The cumulative frequency curve is also called as ogive. Ogive is of two types: less than ogive, more than ogive. The ogive helps in identifying the median and quartiles of the dataset. Now we will see an example on how to draw less than ogive. The following distribution gives the daily income of 50 workers of a factory. Draw its less than ogive. Solution: to draw the less than ogive, first convert the distribution to a less than type cumulative frequency distribution. To make less than type, we need to consider the upper boundary of the class interval. Now, to represent data graphically, mark the upper boundaries of the class intervals on the horizontal, that is x-axis, and their corresponding cumulative frequencies on the vertical, that is y-axis. Now, find the values to be plotted. Now, plot the points corresponding to the ordered pairs given by upper boundary corresponding cumulative frequency. that is 300, 12, 350, 26, 400, 34, 450, 40 and 500, 50. Plot these points on the graph paper and join them by a freehand smooth curve.
We'll cut this and we'll make it zoom out.
By plotting the above points, we get our required less than type ogive. Plot these points on the graph paper and join them by a freehand smooth curve. By plotting the above points, we get our required less than type ogive. Now, let us see an example of how to draw more than ogive. The following table gives the production yield per hectare of wheat of 100 farms of a village. Draw its more than type ogive. Solution. To draw the more than type ogive, first convert the distribution to a more than type cumulative frequency distribution. To make more than type, we need to consider the lower boundary of the class interval. Now, to represent data graphically, mark the lower boundaries of the class intervals on the horizontal, that is x-axis, and their corresponding cumulative frequencies on the vertical, that is y-axis. Now, find the values to be plotted.
After this we need to cut because the camera battery is only 2%.
In total, there are 100 farmers who can produce more than 50 quintals. To get the number of farmers who can produce more than 55 quintals, we need to subtract the farmers from a total of 100 farmers who can produce less than 55 quintals. That is 100 minus 2, that is equal to 98. There are 98 farmers who can produce more than 55 quintals. To get number of farmers who can produce more than 60 quintals, we need to subtract the farmers from a total of 98 farmers who produce less than 60 quintals. That is 98 minus 8, that is equal to 90. There are 90 farmers who can produce more than 60 quintals. To get the number of farmers who can produce more than 65 quintals, we need to subtract the farmers from a total of 90 farmers who produce less than 65 quintals. That is 90 minus 12 is equal to 78. There are 78 farmers who can produce more than 65 quintals. To get the number of farmers who can produce more than 70 quintals, we need to subtract the farmers from a total of 78 farmers who produce less than 70 quintals. That is 78 minus 24 is equal to 54. There are 54 farmers who can produce more than 70 quintals. To get the number of farmers who can produce more than 75 quintals, we need to subtract the farmers from a total of 54 farmers who produce less than 75 quintals. That is 54 minus 38 is equal to 16. There are 16 farmers who can produce more than 75 quintals. This is one way, and another way is we can get directly from the number of farmers. Now plot the points corresponding to the ordered pairs given by lower boundary comma corresponding cumulative frequency. That is 50, 100, 55, 98, 60, 90, 65, 78, 70, 54, 75, 16. Now we will see another example. During the medical checkup of 35 students of a class, their weights were recorded as follows. Draw a less than type ogive for the given data. Hence, obtain the median weight from the graph and verify the result by using the formula. Solution. The given cumulative distribution is of less than type. Now, to represent data graphically, mark the upper boundaries of the class intervals on the horizontal, that is x-axis, and the corresponding cumulative frequencies on the vertical, that is y-axis. Now find the values to be plotted. Now plot the points corresponding to the ordered pairs given by upper boundary comma corresponding cumulative frequency. That is 38, 0, 40, 3, 42, 5, 44, 9, 46, 14, 48, 28, 50, 32, 52, 35. Plot these points on the graph paper and join them by a freehand smooth curve. By plotting the above points, we get our required less than type ogive. Now find the median from the graph. Consider n by 2, that is equal to 35 by 2 is equal to 17.5. Now locate 17.5 on the y-axis. From this point, draw a line parallel to the x-axis cutting the curve at a point. From this point, draw a perpendicular to the x-axis. The foot of this perpendicular determines the median. So, median is equal to 46.5. Let us see. We get median as 46.5. Now we will verify using the median formula. We may observe that the difference between two consecutive upper class limits is 2. We have cumulative frequencies, but we require individual frequency values to substitute in the formula. Now we may obtain class marks with their respective frequencies as below. Total n is equal to 35. So, n by 2 is equal to 35 by 2, that is equal to 17.5. Now observe the table. In the cumulative frequency column, where does the value 17.5 lie, or the greatest value of 17.5? In cumulative frequency, just greater than 17.5 is 28. So 46 to 48 is the median class. We know that the median of grouped data is L plus n by 2 minus Cf by f into h. Find the values of the unknown terms and substitute them in the formula. Then we will get the required median for the data given. L is equal to lower limit of median class. That is equal to 46. N is equal to number of observations, that is equal to 35. Cf is equal to cumulative frequency of class preceding the median class, that is equal to 14. F is equal to frequency of median class, that is equal to 14. H is equal to class size, that is equal to 2. Now substitute the values in the formula, that is equal to 46 plus 35 by 2 minus 14 divided by 14 into 2. After cancelling, we get 46 plus 17.5 minus 14 divided by 7. That is equal to 46 plus 3.5 divided by 7. By dividing, we get 46 plus 0.5. By adding them, we get 46.5. So, the median of this data is 46.5. Hence, the value of the median is verified. Another way of obtaining the median. If we draw both ogives, that is of the less than type or more than type, on the same axis for the same data, the two ogives will intersect at each other at a point. From this point, if we draw a perpendicular on the x-axis, the point at which it cuts the x-axis gives us the median. Students, let us summarize what we have learned. The cumulative frequency curve is also called as ogive. Ogive is of two types. Those are less than type and more than type. The ogive helps in identifying the median and quartiles of the data set. Representing a cumulative frequency distribution graphically as an ogive of the less than and greater than types, or as cumulative frequency curve. The median of grouped data can be obtained graphically as the x-coordinate of the point of intersection of the two ogives for this data. Thanks for watching.